Hey everybody, this is Mrmathblog, and this is solving quadratic systems. So we're solving conics equations. So don't forget, all your lessons can be found at mrmathblog.com. I don't say that too much in my Algebra 2 lessons because I didn't have this website before then. So if we go to that, you guys, let's go to that real quick, you guys. So here's mrmathblog.com right here, and when you go to that, you see all the classes that I've taught right here. So over here is Algebra 2. So if we click Algebra 2, that'll take us to all the lessons in Algebra 2. So here's your whole year right here. And this is 9-7, so I'm going to fit that in right in between 9-6 and the review on the conics right there. All right, let's go ahead and get started with this lesson here. So uh, okay, so in my class I have these things called board problems. So let's do some Algebra 1 skills. Hopefully you guys are going to solve these systems by substitution. So I'm going to do this all at once on the next click. I'll talk us through. So we're going to just substitute in this x plus 1 in for this y right here. Y equals x plus 1. So you can see I did that, then distributed the 5 through, and we get this right here, and then we combine 4x and 5x is 9x, and then we subtract the 5 to get 18, so x equals 2. And don't forget, these are ordered pairs. Can you see that this is a line and this is a line, so these two lines intersect when we plug in x equal 2 right there. 2 plus 1, because y equals x plus 1, so when x is 2, 2 plus 1 is 3, so we get 2, 3. Okay, so that second equation, what I did here was what did I do? Oh, I took this, sorry, took this second equation right here, and I added y to both sides, and then we subtracted 5 from both sides. We could solve for x right here, but you would have had the negative 3y minus 1, and the kids get lost with the negatives, so I like dealing with positive stuff. So I solved for y on this one right here, and then plug that in for this y in the second equation. You could have solved for x and plugged it in for that x. You should get the same thing as long as you're careful. So as you do that, you get x equals 2 and then y equals negative 1. Okay, so this other one, I let x be the number of students and y be the number of non-students right here. Okay, so right here it says they sold 200 tickets altogether. So that's x plus y equals 200 right here. And if it's $3 for the students and $4.50 for the non-students, and it totaled 720, then I get another equation, 3x plus 4.5y equals the 720. Okay, now we have a system of equations. I'm going to solve these guys by the elimination method. So I'll multiply this top equation times negative 3. And then when we do that, we get negative 3x minus 3y, and then this time negative 3 is negative 600. Then we can add this red one with this one in right here, and then when we add that, we get 1.5y equals 20, and then it's all downhill from there. So we get 120 students that went and 80 non-students. Okay, all right, so when we solve quadratic systems, you guys, just think of the conics. We had ellipses, we had hyperbolas, we had parabolas, so you can see all these things. They can sometimes intersect as you can get one solution, two solutions. So we're going to be using the same techniques that we just did in that board problem right here. Sometimes we'll get no solutions, and so when you get no solutions, you might have a picture like this, like a parabola right here and a line. They don't intersect, or a circle and a line, or here we have a parabola and a circle not intersecting, or we could have two ellipses not intersecting, or even an ellipse and a hyperbola not intersecting, so there'd be no solution. Sometimes we'll get one solution. Okay, so here's a line and a circle intersecting right there. Here's a parabola and a line intersecting right there. Here's a parabola and a circle intersecting right there. So there you might get one solution. You might get two solutions. Can you see this parabola and circle intersecting in these two spots right here? Here we got a line and a parabola intersecting in those two spots. Here we got another parabola and a circle intersecting in those two spots. Can you see two circles intersecting in two different spots? How about an ellipse and a circle, or hyperbola and a circle? You have to kind of think about it a little bit, but it can. Here's three solutions. Here's an ellipse intersecting a circle in three spots right here, and here this circle and this parabola are intersecting in three spots. Here's four spots. So you can get up to 0 to a 1, 2, 3, or 4 solutions on these guys. All right, so let's solve each system here. So here we have a parabola and a line right here. Can you see a parabola and a line intersecting, maybe in no spots or one spot or two spots? So what I'm going to do is add y to both sides and subtract 3 from both sides and get y equals 2x minus 3 and substitute it in right there, okay? And then we got to square that. Be careful, 2x minus 3 times 2x minus 3. FOIL it out, it gets us that right there. Then we're going to combine like terms, and then we're going to go ahead and factor this. Now, if you're good at guessing and checking, fantastic. I call it smiley face factoring. If I multiply these outer two numbers, 4 times 12 is 48, and other factors of 48 are negative 16 times negative 3, and those pair add to that one right there. This is how I teach this kind of factoring. So we rewrite that, replacing this negative 19x with these two numbers, negative 16x minus 3x. And then we group the first two together, group the second two together. Notice this negative pulled out, so it changed this plus to a minus. Imagine if we redistributed the negative back through, it'd get us back to there. And then we GCF these two guys. I can pull a 4x out of both of those guys. I can pull a 3 out of both of those guys. So when we do that, then we're left in each of them with an x minus 4. And since they both have an x minus 4, we can GCF that out, and we're left with the red stuff that it was attached to it. Now we got the zero product property. This factor equals 0, or this factor equals 0. So we get x equals 4 or x equals 3/4 on that. Now, these are points, they're ordered pairs, so we got to find the y coordinate. So I'm going to plug in x equals 4 right there. 4 times 2 is 8. 8 minus 3 is 5. Then plug in 3/4. 2 times 3/4 is 3 halves. 3 halves minus 6, or sorry, 3 halves minus 3 is 3 halves minus 6 halves, which gets us a negative 3 halves right there. Okay, so our ordered pairs are 4, 5, and 3/4, negative 3 halves. Okay, so here this parabola and this line intersected at these two spots right here. All right. So here we have, looks like another parabola right here, because only one of them's being squared in this circle right here. So we can have one solution, no solutions. We might have 3 solutions. We might have all 4 solutions. Okay, so here we go. I'm going to show you a different technique right here. We can use substitution if you want to. We can solve for that y and substitute it in for that y and square it, make sure you don't mess it all up. Or we can go ahead and subtract, because the x squares will cancel out, you guys. So I put bluey right here and then reddy down below, and then we can subtract. So when we subtract, we get y squared plus y minus 3 equals 9. Then we'll subtract 9 from both sides. Then we'll factor that, and there we get 2 y values. So when y equals that, then I'll go ahead and add y to both sides. So I get y equals x squared plus 3. So we'll plug in negative 4 for y. So when y is negative 4, whoops, I should have done it on a different slide. I get negative 4 equals a number squared. Remember, a number squared is positive, or 0, plus 3. This is always positive over here, so it will never equal negative 4, so that's why I crossed off negative 4. I can never make this side be negative to make it equal to this side, because this side's always positive. A number squared plus 3. Okay, so then when we plug in 3, you guys, y equals 3 right there, then we subtract 3 from both sides, we get x squared equals 0, so x equals 0. So this only intersects in one spot at 0, 3. Okay, so that's our only answer. This is where this parabola and this circle intersect, is at that one spot. Okay, here we have an ellipse and we have a hyperbola. Okay, what I'm going to do is add these equations together right there. Okay, so here we go. When we add them together, the y squareds cancel out, so we get 10y squared minus, or 10x squared, sorry, minus 90x plus 200 equals 0. We can divide everything by 10, then we can factor, and when we get those x values, then we just substitute it back in. I plugged it in right there, so I plugged in x equals 4, so 4 squared is 16. So we get 16 minus y squared equals 16, so the only value we can get to balance that out is y equals 0. Now we plug in 5, well, it gives us that ordered pair. So when we plug in 5, we get y squared equals 9. So don't forget, you guys, y is plus or minus 3. So when x is 5, we get 5 comma 3 and 5 comma negative 3. So this ellipse and this circle intersect in 3 different parts right there. All right, let's try one that gives us a no solution. So this one's going to give us a contradiction right here. All right, so here I took this bottom equation and solved for y, and then I'm going to substitute it in for that y and that y right there. And when we do that, we get that mess right there, and then we distribute the negative through, and then we combine like terms, and what happens is all the x's cancel out and we're left with negative 63 equals negative 59, and that's not true, so that one would be no solution. Okay, all right, if you're in my class, I would assign you that for your homework. Take care.